All right, so this one's you.
Yeah, today, we are gonna begin today's morning session is a virtual lab that we have created. The three of us actually have created this classifying matter. And I'd just like to begin with saying this is the intention of this is a middle school science teacher professional development. Obviously we're virtual again this year. And that was kind of a request last year. We were kind of kicking around the idea of maybe going back to an in-person. And there are kind of a few things that got in the way of that this year, but also we had a lot of feedback at our sessions last year that if we went in person, there's a lot of people that wouldn't be able to make it to campus because they're too far away or whatever. So we're continuing this virtual PD, even though this is like billed as a middle school professional development. There are applications in other areas as well. So where
you said you would use it.
Yeah, I would use it. I taught chemistry at a lot of different levels. I taught high school Chem 1. I taught the integrated chemistry physics, which was more conceptual, wasn't quite the Chem 1. It was a different focus. I taught chemistry 2. I taught AP chemistry. But I'm telling you that this classifying matter virtual lab that we've come up with, I think would have been appropriate for a chemistry 1 class, but I also feel that it's appropriate at the middle school level as well. And there's ways that you could differentiate that. So Stephen and Bill, actually, how are we going to begin sharing this website? Are we going to put the website in the chat, or?
Well,
are we just going to share it?
Now, normally you're the control freak, being the control person,
Okay,
and now you're like asking. This is like.
I'm taking your feedback that the control freak that I am, and I'm trying to see what I can do to.
Oh, that's it first.
Okay.
Yes, we're recording, Bill. You already said that. We want to share screen?
Yeah, we'll go ahead and share. Stephen did put the link to this virtual page in the chat, but we will also be making this live and posting about this on our Facebook and Twitter feed as well. So here we have our classifying matter. Now I would like to begin by pointing out the request and answer key. What we're going to do here is we're going to have the keys for like the guided notes, everything that we're going through. An example of an answer key that you could use just to save you some time if you wanted to see like, okay, what should I be looking at? Go ahead and complete that. This is more just so that we can get information on who is using this and where it's being used and how. This is also kind of a safety for us so that we're not putting answers out there for students. One of the things we're asking for is the school website, and that's just to make sure that, yes, you're a teacher at that school where you are, and you're not one of your students trying to hack in.
And they've tried on some of the others.
Yeah, we've had a few.
Yeah, if we can't find you on this, and if you're like new to the school and you're not in the website yet, yeah, I mean, you're going to have to sell that because your kids are lying.
Right, they're going to tell us all kinds of things to try. And you know, us having been teachers, we get that. So we will. We
know not to trust them.
Right. So that's what that is initially here, and I'll be happy to provide answer keys to anybody that would like it. With that being said, I would like to personally ask that you don't share those answer keys with other teachers, but instead just send them that link, and I'll be happy to send it to them as well. This is just helping us gather that data that we need for our impact, the reach that we have. We will give this to any teacher that wants it, but again, we're just trying to, when you just visit a web page, we don't know, we can get hits off the web page, but we don't always get an accurate.
Yeah. It's kind of one of those things for us to have funding to do things like this.
Right.
To build, like the kids that, I know we're only limited to kids, and some people are like, we didn't get a kit. Sorry, we spent how many thousands, Will? Total? It's probably close to 10, 11, 12. What were you at?
We spent $20,000. Did
we spend that much?
My word.
Yeah, well,
yeah, sorry.
I hate to, hopefully, can we pause the recording so I can say the next thing? I will say kudos to you. You're a good politician getting that money. $20,000 worth of kits we sent to teachers. And you're welcome. Some teachers were like, yeah, we didn't get one. And I know they're a little frustrated, but I mean, we can only do so much.
Yeah.
It's,
if we could help everybody, we would. And it's at some point there.
But the reason that Sarah's asking for you to not just give the other teacher the key, but ask them to ask her for it, is because that way we put that in our metrics for our grants. Yeah. When we ask people for money, so we can buy more kits for more supplies for teachers, because all the money goes to the teachers. I mean, we have keep just enough to do it ourselves, but then the rest of it all goes to the teachers. We don't have to pay our salaries or anything. Everything we do is to support teachers teaching science.
Yes. So with that said, We have structured our lessons slightly differently this year. We're putting it more, and we have received some feedback from one of our favorite teachers at a conference that we went to earlier this spring about we need to, it would be great if we could include more of a phenomena-based or an engagement piece into these. And so that is a really great idea. So we're taking that. We want to see how you like that this year. We're going to start, I've placed some learning objectives here. So as you go through this lab, kind of what would the students be, you know, what do we hope that they're going to be getting out of this? And that's something I know when I left the classroom that my school was really starting to point out. They wanted to see those learning objectives every day on the board. And I thought, oh, okay, like that was kind of where I was going. Had I not come here, that's where I would have been heading next, identifying those. And so hopefully that's helpful to some of you. But we have our overview here is kind of starting us with this engagement piece. And we're going to see a link to a guided notes worksheet. And again, the key at the top where you could click on that link, you know, I'll have be able to share with you a key that I've made up from that. But all those answers are going to be able to be found here in this overview. And basically, this is kind of setting students up. You know, science is learning how to ask questions and make observations about the world. And that kind of brings us into this thing that everything around us is matter. And so matter is anything that has mass and takes up space. And that when we can sort matter into categories using similar characteristics, we can help, you know, we can then make better observations and more accurately answer questions that we might have. And so we're starting this piece with, you know, what if we want to go down and pan for gold? It's a really fun thing. I know we've gone down to we have word near the Wabash River, and we've gone down a few times for different events and taken a gold panning thing down and thought, you know, what if we find something here? How do we know for sure if what we've got is gold? I don't know. I mean, I'm just looking at it, looks glittery. I don't know if it's gold or not. So we said, well, we could begin by answering this question by observing some physical properties of the sample that we collect. And so, you know, we're talking about matter, we're talking about physical properties. I struggled a little bit. I'd really like to put something about chemical properties in here as well, but it just didn't fit. And when we were creating this, I didn't really feel like forcing that in there. So really, we're just really looking at observations that we can make right now, physical properties. That physical properties are observations and measurements that can be taken without changing the identity of a substance. So if we're we're thinking, oh, we're on a pan for gold. Do I have gold? Well, we can look at some physical properties of gold. We know, like maybe its formula. Gold is AU on the periodic table. Gold would be more dense than maybe fool's gold, which is less dense. Pyrite has a formula very different from gold. Pyrite is an FeS2. A hardness is a physical property that we could look at with a scratch test or something. I thought it was interesting. I didn't know, just looking at this, that gold has a hardness about of a fingernail. I've always heard that it's soft. I didn't realize it was like similar to I thought, well, that's interesting. And that pyrite would be harder than what gold is. And that they respond.
It is slightly harder than a fingernail.
Yeah, well,
It's
yeah.
harder than a fingernail.
Gold
Otherwise, it would like.
Well, but is that pure? That would be mixed like an alloy, right?
Oh, yes, our fans are whatever number.
Yeah. I don't know.
I don't know either.
Maybe I shouldn't trust everything I read on the internet either. Maybe it's not. I don't know for sure. I'm not a.
All right, someone look that up, fact checker.
This is just what I was just Googling things.
I don't believe this one.
But okay, well, it's not. I don't know. It says a hardness of 2.5, so that's. Anyway, so is my sample that I'm collecting, is it gold? Is it fool's gold? Well, we're looking at the formulas listed. Real gold is represented by the letters AU, and we already talked about that. And this combination of letters can be found on the periodic table. And this is kind of going to play then into the rest of this lesson. And we're looking at, for one thing, the formulas of whatever it is that we're observing. If it can be traced back to the periodic table, which lists all of the known elements, that first of all, if it's just AU, for example, and it can be traced back, that makes it an element. Elements are a type of matter that we call pure substance, and they can't be broken down into simpler substances, right? We know that that's the thing about elements, and they're made from only one type of atom. And but fool's gold, so for example, pyrite, we can find Fe on the periodic table, but we can also find S on the periodic table. So it's a combination of a couple of different elements, and so we're going to call that a compound. So compounds are made from two or more elements that are chemically bonded together. And compounds are a second type of pure substance. And compounds always have that same ratio of elements. So for example, pyrite's always going to have 1 iron to 2 sulfur. Now, Billy, I saw where you do. I want to pause.
No.
Okay.
No, you're fine. I have a question, because I think this question was asked to me by a kid.
Don't get coffee when you ask a
Okay.
question.
So when you have an element,
Uh-huh.
so when they bombard it, and they can actually break that element down.
Yes.
Is that not breaking it down into smaller particles?
So-
How does that?
It is.
Like-
So that's a really great question, and I would get this a lot too,
Yeah.
in chemistry, because you say, "Oh, you can't break it down any farther." It's
And then you
the
start talking about electrons and neutrons and
Yeah.
protons. The kids are like, "Now wait a minute."
So then that brings up a clarification that yes, that's the simplest form of matter that you can get while maintaining those same properties. And so that gold atom, you get down to that gold atom, it's still going to have those properties of gold. But then if you break that atom down, now we don't have those properties of
We
gold.
don't have
Now
gold
we're talking
anymore.
about the subatomic particles that make it up.
Yeah.
So that's a really
No,
great
right,
question
and I think
because-
that is.
because kids, like I know my own kids are like, well, like if I tell them it's this, they're like, well, Mom, what if it's this? You know?
You start
Okay,
talking-
well,
You start talking about a particle
How did you
accelerator,
say
they're like, "No, wait a minute."
How do you say it? It's the smallest you can break down and still what?
still retain its properties.
So at that point, it still has the density of gold.
Yes,
Yeah.
It still has the mass of gold.
right.
I mean, so it has all those properties.
Yes, yes. And yeah, yes, it can be broken down, and actually the protons and neutrons and electrons can be broken down farther than that.
I saw someone said they're having troubles hearing. Hey, can everyone else hear us all right?
Does anybody?
Got a no? Yes? And there were way too much.
Very soft. It's no, it's
Can we turn
low.
this up? Is that what we do here? Volume?
Okay, we're getting all kinds
It's,
we're talking fast.
we're talking fast, that's usually what I do. Yes, but occasionally it goes out. Hopefully it's not that much.
Okay. You know what?
Give us a second. We're gonna adjust this a little bit because we definitely want to make sure you can hear.
That cable.
You have something that it went too fast.
No, we have one microphone that we're all using.
Okay.
It-
Try that. It might have been the
That was better?
Oh, I'm
Perfect.
talking too fast.
You're talking
Okay.
too fast.
So we need to
Sorry.
slow down our talking.
Jake says we're fine. I think we're
Someone said to project.
fine.
So
Project,
use your stage,
really.
use your stage voice.
People tell me I talk too loud, so I'll project more, and that I can do that.
Okay, we will slow down our talking and we will project more.
Don't talk over each other.
And if someone can't hear us, just send a message and I'll look at it.
Yeah.
Thank you.
Thank you for the feedback. This is helping us. We appreciate that. If you missed it, just a recap of what we were talking about. Bill asked where we said that that an element it's only one type of atom. Elements cannot be broken down into simpler substances. And Bill said, but what if you bombard an atom and break that down? So atoms then would be made up of protons and neutrons and electrons. So wouldn't those be simpler substances than an atom? He said yes. So what is meant by that is that elements, when you get down to that, like a single atom of gold, for example, that's the smallest you can go and have it still retain those properties of the gold. So its density and its hardness and those sorts of things. If you then break that one atom of gold down, then it no longer retains those properties of gold. So that's what we were discussing, I think, then when we were getting some of the feedback that was difficult to hear. Okay. Compounds always, like we said, we kind of ended there. Compounds always have the same ratio of elements. So if we were comparing that pyrite to gold, that it would be one atom of iron to 2 atoms of sulfur, and that it would always be in that ratio, even if we had other Pure substances, which are one type of matter, can either be elements or compounds. And so we've gone from matter, and now we're differentiating between pure substances, which can then scale down between elements and compounds. But what if so back to our panning gold sample, what if we're panning this gold and it's not gold and it's not fool's gold? Because how likely would that be that it would be down to gold or fool's gold? What if it's just a combination of things, like a mixture? So mixtures are another type of matter, and mixtures can be either homogeneous or they can be heterogeneous. And we have more tests that we can do then to differentiate types of mixtures. A homogeneous mixture is also known as a solution. And when we start talking about mixtures, the really key factor with differentiating between what type of mixture it is going to come down to particle size. A homogeneous mixture or a solution has the smallest of all the particles. Small particles mean that the composition is going to look really uniform. Now, this can be a little confusing as we go through helping students learn how to classify things. In fact, recently, my own kids are kind of getting to that middle school, high school age where they've been doing some of this, and they say, well, a homogeneous mixture looks the same throughout. And it does, but there are also some heterogeneous mixtures that can look the same throughout, but technically they're not homogeneous, they're heterogeneous. So again, I really want to focus on this idea of particle size. The smallest of the particles that, again, it's going to look uniform throughout, are going to classify this as a homogeneous mixture or a homogeneous solution. It's a type of solution. The particle size of a heterogeneous mixture, to compare, they're large enough to distinguish the different parts of the sample. So something that we can do is we can shine a beam of light through a heterogeneous mixture, which is a different type. And if it's heterogeneous, those particles are starting to get large enough that they can scatter that light. It can make the mixture appear as though it's glowing or illuminating. But also, it might not illuminate because those particles might be large enough that they actually block the light. So it can make the solution appear to be glowing with a beam of light, but it can also not glow. It can also just kind of stop the light because those particles are too large. When we shine a beam of light through a homogeneous mixture, that beam of light will pass straight through because the particles are so small that they're not going to block or scatter that light. And so this test that we use with passing a beam of light through, when that light scatters, that's called the Tyndall effect. And the Tyndall effect is a quick test that we can use to determine whether a mixture might be homogeneous or heterogeneous. So we're going to show some examples here in a little bit. What's that?
A little bit. That's the fun part. When are we going to get to that?
Oh my God, we got to get through the.
Oh my God, your lecture. I'm that child. I'm that child.
They told us not to talk over each other. What are you doing?
I paused before I started criticizing.
That's true. You did not. Good job.
I'll drink my coffee and shut up.
Now, let's say that we observe the Tyndall effect, or we don't observe the Tyndall effect, but we use that beam of light, and we have it classified, and now we know we've got a heterogeneous mixture. Well, now a heterogeneous mixture can be differentiated even more. It can be categorized even further. It can become a colloid or a suspension. And again, this is based on particle size. Let me make sure I say the right here. Suspensions are the largest of the particles, and they can be easily separated by just sometimes gravity will just separate it out. Sometimes filtering or gravity filtration will allow these large particles to filter out. Where a colloid's particles are smaller than a suspension, but they're larger than a solution, and they're never going to settle out. Well, I shouldn't say never because there's always exceptions, but it's rare that a colloid's particles might settle out or be filtered out. So again, I want to come back to that homogeneous mixtures are the ones that always look uniform, and I think that we hear that a lot. But I would argue that sometimes a colloid looks uniform. For example, milk is a colloid. And I hate to give this away because that's in our pre-lab that we're going to look through, but milk looks uniform. And I think I've even given that example like before, like when I was teaching, like, oh yeah, milk's homogeneous. But really, well, we'll see. Perhaps milk could be classified more as a heterogeneous colloid than it could be classified as a homogeneous solution.
Don't they call it sometimes homogeneous milk?
Yeah, right.
Homogenized or
Yeah.
whatever.
Yeah.
Well, and
What's that question? That's all pop up. I had that question too. Homogeneous. These are big words.
Homogeneous and homogeneous.
yeah, homogeneous and homogeneous. I think I've been saying I pronounce it homogeneous, but I think I've heard other people pronounce it homogeneous, and I don't.
Yeah.
It's the same. Yes, it's the same. And I apologize for. It's probably just like lightning bugs and fireflies or something. Different ways of saying the same thing, probably is my guess.
All right.
Okay. So in this virtual lab, what we've done is we've taken a lab. I did this lab a lot, but I never had it as a virtual option until now, where we would set these samples up because I always think it's important for the kids to have that hands-on, making observations, really observing it in real life. What do these look like? What are the physical properties of these, and actually testing them as much as possible. I think that's the kids enjoy that more. It's not just like they're copying vocabulary words out of a textbook. They're actually getting in there, they're taking a look, they're making those observations, they're trying things out. But we know that the world changes, and that's not always a possibility. And so what we've done, this is definitely something that you could set up. We're going to have some possibilities of samples of matter that you could provide for classes. But there are, of course, many other examples of matter that you could also provide. It all depends on what you have available, what you have in your cabinets, what's easy for you to get a hold of to present to your students. But in the chance that you have a student that can't be in class for whatever reason, hopefully this will be helpful to give them the next best thing, which is this virtual lab. So we're going to, this virtual lab, the point of this is to have students classify some different types of samples. So as either homogeneous, heterogeneous, or elements or compounds. Okay, perfect. Yes, and a solution, I'm going to say, is synonymous with a homogeneous or homogeneous mixture. That's what solutions are describing, and that if it's a heterogeneous mixture, I wouldn't use the word solution to describe that.
The chemistry people.
Yeah, that's just not what it. Now, I'm not saying that that's like I could be wrong, but that's been my experience going through that. And again, I found after a lot of years, it's getting down to that particle size that's helping us differentiate that. So we get to our procedure, and I didn't include right here with the safety glasses. Of course, safety is always a thing, and if you're actually in the lab, definitely safety glasses. Definitely you want to think ahead of time before you give those samples, like what will my disposal procedure be? So if it's something that would be difficult to get rid of, maybe find another alternative, because disposal is a real thing. Like we have to be really conscious of what it is that we're putting in the trash and how we're disposing of things that we provide. Even if it would be an awesome thing for students to observe, like mercury, we can't. It's just not always a possibility. But I didn't put in right here, or we didn't put into this procedure using safety glasses because this one is all online. So this isn't something that,
But if you do it in
person, in person, you would consider using safety glasses, even if we were just using.
I can add that to the lab.
Yeah.
I'll add that to materials.
That's good. Yeah, that'd be good.
Write that down. So the question was asked.
Yeah.
Can solutions be?
I'm gonna say solutions are homogeneous mixtures, and I would not use the term solution for a heterogeneous mixture. Instead, I would call it either a heterogeneous colloid or a heterogeneous suspension. That's what I would say.
And I would do the same, because I mean, kids would go, "Can you just throw that in water?" And does that make it a solution?
Right.
No, I mean that really makes it a suspension.
Yeah, and again, I want to really drive home that idea of particle size, that it's a solution when those particles are really small, and they wouldn't scatter light. They're small enough that they wouldn't be scattering light. But that's when we have that homogeneous solution. and that the term solution goes with that homogeneous mixture. So for this procedure, we're going to be looking at some different samples of matter. For this piece, it's all online. And so you're going to see a picture of each sample. It's all linked. We're going to use the sample ID, which is column 1, to determine which samples have parts that might appear on the periodic table. And that's one of the first things we're going to do to start separating between what are my pure substances and what might be my mixtures. So that's our first order of separation here. What are pure substances? What are mixtures? Once we have that separated, once we have identified what our mixtures are, then we're going to have a series of videos where we first apply the Tyndall effect. We're going to show a laser. We chose to use a laser because we thought that gave us the best results. You don't have to use a laser if you're doing this in person. You could. I've used a flashlight before when I've done this lab in person. I think you get, if you have access to a laser, you're going to,
It's cooler.
it is.
It's freaking awesome. It glows. It's awesome.
The visual experience is cool. A flashlight does it too, but a laser just really seems to up that wow factor.
And for those of you who got the supplies, the lasers that you got were, and those of you who don't have the supplies, you can order those if you just type in cat lasers, believe it or not.
Yeah.
These are for cat toys to play. You get a 3-pack and they're dirt cheap. So that's what we ordered. It was pretty easy. Yeah. So there you go.
If the laser light does not illuminate the sample, then we're going to classify that as a homogeneous solution. If it does illuminate the sample, then we might call that a heterogeneous, but not all heterogeneous mixtures are going to glow because, again, sometimes the particles will be so big that they kind of trap all the light. It just doesn't pass through it all. So I'm going to say it can glow, but not always glow. So here we go. And for each of these, look for your copy of the worksheet that goes with it. So again, when we started the overview, this is something that the students could go through and read this and complete. It's pretty short. I think I had 10 different questions because, well, I thought 10 was an easy grade to take, 10 points or whatever you wanted. That'll give you an example of that. Again, the link at the top of this web page is where you can request that answer key. If you fill that out, I'll email that straight to you, and that way you have that for your own records. But we aren't going to email those keys to students, and we'll double check. For the pre-lab worksheet, if we click on that, I'll click on this one just so you can see. It's gonna, I don't want you to get startled. It's not some kind of virus or strange thing. This is something we can do with Google Docs so that it directly puts a copy of it straight to your drive. If you use Google, like G Suite, or if you have your own Gmail account. I know here, there's a lot of different schools that do utilize that, but not all schools. Not all schools are using Google. This will also work with other learning management systems, even though it's a Google product. I know that it can work with Canvas and it can work with but definitely you can make a copy of this straight there. When you click make a copy, now it's getting put directly into your drive. And I did include a picture up here. This is also part of the guided notes, that in case they miss that or you don't feel like assigning that, this is kind of showing that hierarchy of how we're separating out matter. And this is exactly corresponding with the pre-lab. And so this is something that you could print off and the students could complete as they're looking at this. Or, you know, they could make their own list and do this. These are the materials these are just what we used. There are many other examples. I think this is the first time that I've done this using a carbon sample, which I thought was cool. We got some carbon rods. You could also use a piece of charcoal. I think I just didn't want to buy a huge bag of charcoal briquettes and then have a ton left over. So this is a little more manageable. You could also use, I think before I had a whole bunch of sulfur, like powdered sulfur. So I just put a little bit of sulfur in a little wave up, and that was the element that we used there. I guess I'm giving it away. But you don't have to, you can definitely vary the materials that you're using. But it's also important that we have an example of a periodic table. And this is something that my department of chemistry here, that they actually have this periodic table on their departmental page. That's one of the ones that they show. It's the Royal Society of Chemistry periodic table. I think it's kind of a cool one. They also have links to an app that you can use. But I like that they're showing you kind of pictures of them. They give them some, of course, the electron configurations and the density and different things. But also you can, down here they can show on the app that you can download it. But I also like the temperature slider for this one. So right now it's at 0 Kelvin and you can see the states of matter, but then as we increase it, you can start seeing those changes to liquids and gases. And
So I got a little side story.
yeah.
So I taught in Phoenix, Arizona, actually in Tempe, and Intel was right next door. And I worked for Intel one summer. And then the lady that I worked for came into my classroom. This was 1991.
Okay.
And she brought in computers, and they had just developed an interactive periodic table. She was so excited. And
Oh,
so
wow.
and that's the only thing on the computer was the interactive periodic table. But the kid would click on it, and all it did was give information, no picture, nothing, just like what's the density,
Oh,
that was it. But that was
well,
revolutionary at that
yeah,
point because
right.
that they had never had anything like that.
do you remember how far did it go?
It did not. I want to say I don't remember ever having.
Like,
I think it did every one, but not the of course not the ones that have been discovered since.
I'm impressed. I mean, 5 years ago, we didn't have symbols. These were still like UUO.
Yeah, right. No,
and
that's what I had down there.
And
Yeah.
and now we even name them all. So I'm impressed with that. I think that's
very cool.
so. Getting back to anyway, we have a copy here. You're welcome to print that off. That's going to correspond with the charts that we're seeing here. As we were making this, one of the questions I think was, why are these blocked out?
Yeah, that's my question.
Yeah, well, these are blocked out because these are solid samples, and we're not able to apply the Tyndall effect test to these solid samples. The Tyndall effect can only be applied if it's like a liquid or some kind of aqueous sample that we have. So what we've done here, we see this carbon rod. It looks like I can click on it. And if I click on it, Stephen he linked it to a higher resolution picture of the sample. It's the next best thing to being in the lab, but what I like about this is you can see a little more definition. You can't necessarily hold it, not that we would or wouldn't hold samples. Some are probably safer. This is probably fine to hold in real life, but you can see a little more detail. It does look, I mean, this kind of has that brittle appearance to it. So that might be one of the ways that I would describe.
I have them popping up in a new window so you don't lose.
Oh, perfect. Okay, yeah,
Designed it.
thank you.
But the cool one's not those. It's like in the lab, the sugar and stuff.
Yeah,
like this.
you
I
can
got
really
good
see
detail
it.
on this when I took that picture.
I'll click on sodium chloride just to see here. Yeah, I think this one looks great. You can see a lot of detail in this. In this one, we were using a kosher salt. I think you can see those flakes a little nicer for that. But you could certainly use just a. This does not have iodine in it. So this would be just sodium chloride. And so what we're doing is we're looking at this very first column, this sample ID, and you're going to see, okay, carbon is a C, and sodium chloride is an NaCl. But then we see sandy water, and the difference between these is we see sand and water. Well, this is what I would have my students do then, is say, okay, we're looking at this ID. If we go to our periodic table, is there a box on the periodic table that matches with any part of it? So if I start with carbon, I'm like, okay, well, C. If I go to my periodic table, well, there's a C. Hey, it matches. So if it's on the periodic table, then we're going to call this a pure substance. Right? If I go back to my table here and I see sodium chloride, it's an NaCl. Well, I have had students say, actually, it was my very first year teaching, and this poor kid, he was taking a test, and he was really just frantic, and he was looking around, and we get to about 10 minutes left in the class, and he comes up to me and he goes, Mrs. Nern, he said, I've just been looking, he goes, I just can't find sugar anywhere on the periodic table. I said, oh, John, sugar is not on the periodic table. Like, the parts of sugar are on the periodic table, but sugar does not have its own box. And I felt so bad. He had spent that whole hour just looking for a box that said C6H12O6, and it's not there. And so it's kind of like with the NaCl. They're not going to see a box that is NaCl. What they're going to see is they're going to see a box for Na, and they're going to see a box for Cl. And because those pieces that make that up are there, we can then call that a pure substance because it's a combination of two or more elements that are chemically bonded that's making this a compound. And a compound is a type of pure substance. So then you might say, going back to our overview, like our engagement piece that we had, pyrite is FeF2. Okay, well, I see my Fe, I see an S, but I don't see an S2. So what do we think?
Be multiple ones.
The S is there, and the S2, we know, is two of these sulfurs, one sulfur and another sulfur, for every one of these ions. So the fact that the little number isn't with it is fine. The little number is just telling us how many of those elements make that ratio, because in a compound, it's always that same ratio, whatever that is. If we're thinking about like a glucose, C6H12O6, we see a carbon, we see a hydrogen, we see the oxygen, and it's telling us it's always in that ratio. We would have 6 carbons and 12 hydrogens and 6 oxygens. That would make it a compound because we can trace the parts of that compound to the periodic table.
I thought it was the version number.
Yeah, 2.0.
2.0. I want to pause you just for a second. So to explain to everybody out there, we work at Purdue University, and because Purdue University is a land grant institution, we by the rules of a land grant institution, we have to give back to the community from which we serve, and so we don't charge for things. We're not selling anything. We're not trying to. So thank you for the comments about how nicely done this is, and do we sell these anywhere else? We don't sell them. This will be on our website, and we will continue to develop labs like this. We've been told by teachers enough that we're going to continue to do this. So you will have access to this lab, and we will continue to develop labs like this.
Yeah, and we'll show you where the others are.
Yeah, we'll show you where other stuff.
Because we have others we've been creating, and a lot of them is just it's by the request from you guys. No, Indiana's not next gen, but it's their standards, like a lot of states, are based off of next gen. And so we're trying to kind of gear everything towards next gen when we do things, when we do our bigger things now, just so we can help more people. I'm looking at the mic instead of the camera. What am I doing?
And I think on that same vein, if you're going through and you're like, if you like this, or if you think, oh, I maybe would have done it this way, it's absolutely, I mean, we would love feedback like that. But also, we would love to hear, it would be awesome if you would make this virtual lab. We can't promise we'll make it next, tomorrow or next week even, but we would definitely queue it up to put in our plans for, our next thing to focus on. We would love to hear.
If several teachers ask for something, we know, people are going to use it.
Right.
Because it's the big thing for us is our impact. No, we don't charge for things, but those numbers that we get are proof to the university that we're doing what they want. And that's what helps us get funding for grants and stuff like that with our faculty. And so that's all tied in. And without feedback, we're going to create something. If everybody's using it, they're, this is great, they download and use it, but they don't tell us that, this is useful to us. Yeah. We're going to assume it's not. We're going to move on to something else.
Right.
And so please make sure you give us feedback on things, just to make sure we're getting you what you want.
And that kind of ties back to what we keep saying at the very top of this page, is that request for a teacher answer key. That's feeding exactly into that. We don't always hear or know when or if teachers are using or if they're finding any of our things useful. We don't always know. And you know how it is. Like, you get bombarded with people that want you to take surveys every day, multiple times a day. And we don't like to, like, we would love the feedback, but we also know you're busy and your time is valuable. We're not going to do that.
Yeah, and we don't, it's like if you signed up for this, we're not going to give somebody that email.
Oh, no.
And we have people ask for it all the time. Hey, I need to email this survey to teachers. I'm like, good luck with that. We'll put it on our Facebook page. Maybe some see it. I'm not emailing it to teachers. We try to protect you against as many parasites as we can, because there's a lot of them out there. And so it's,
Yeah. That's
well, when are you going to do the sales pitch for the superhero science?
Well, I'm getting that.
You got it ready? Okay.
Keep going. We're not there yet.
Oh, so anyway, Na and Cl. But now we get to sand and water, okay? So we go to our periodic table. There is no box for sand. You can look all day and all night. No box for sand, all right? There could be boxes for parts of the materials that make up sand, and I don't know what all those are. What about water? Okay, well, water's H2O, right? Well, there's an H, there's an O, and I already know it can be two of the O's and one of the H's, great. But the thing is it's yeah, water's part of that mixture, but also sand is part of that mixture, and we don't know what all is in that, and it's a lot of different things, more than what we can quantify just right from these boxes. So because we can't relate it directly back, any piece of this directly back to the periodic table, ultimately, yes, we would get there, but it's different from just an NaCl or different from just a C. So that's what we mean. We can't directly trace it from this right to the periodic table. That's when we're going to say no, it's not on the periodic table. This is a no. So yes, yes, this is a no. And so if it's a yes, then we're calling it a pure substance. If it's a no, we're calling it a mixture, right? And this is how we're differentiating those. Milky water, again, eventually, yes, we could trace all the parts and pieces that go into milk. We could trace all those to the periodic table, but right now there is no square on the periodic table for milk. There is no square on the periodic table for a sports drink here. I hope this is okay that
Well, it's powered. It's made by Coke.
Coke, okay.
That's the one that I didn't get fired for having.
Okay.
We had a
Seems like our
different
brand.
one out before at a state fair, and the provost of the university came and had a little side talk with me.
Cool.
Yeah, they have a contract with Coca-Cola, so I
okay.
could show those without getting fired or reprimanded.
And I appreciate that you know these things because I would just put whatever.
I know because I've got in trouble for years.
So, okay, so we've gone through, right, we can do this, you know, and I would always do, I have this pre-lab here with the intention that you would go through this one by one with your students and kind of walk them through. Again, this is going to totally depend on, you know, which students you have and how that's working now with your classroom and with students in class and not in class. But if we were all in class, we would definitely go through one of each example so that the students would kind of, we could talk it out, they could hear my reasoning as we're going through this, because then they're going to be on their own for this next part.
Question, so you're not differentiating between compound and mixture?
We will differentiate between a compound and maybe I don't understand that right. So
That's with the filter.
yeah. So if it's an element or a compound, then that's a yes because we can tie it directly to the periodic table, and that's when we would call it a pure substance, right? And then once it's a pure substance, then we can determine whether it's an element or a compound. If it's a mixture, okay, if it's not directly traced to the periodic table, then we're going to call it a mixture. And then from mixtures, our next category down then is a solution, so a homogeneous solution or homogeneous solution, or heterogeneous colloid or heterogeneous suspension.
Is that on the worksheet?
Yeah.
Right? That's on the worksheet, right?
Yeah. So if we go back to our pre-lab note, okay, well, actually, I guess we don't necessarily do that here, but I'll show you where that is for our data analysis.
It's on the data. Yeah,
Yeah.
the other worksheet, right?
Yeah.
Okay.
Yeah. We'll get to that one. So I guess I didn't say that yet. So right now, the first order is trying to determine whether it's a pure substance or whether it's a mixture. Once we have it down to a mixture, then we'll differentiate those, you know, homogeneous solution, heterogeneous colloid, heterogeneous suspension. The pure substances we didn't really do much with yet, but we'll see those here once we get to class. So that's something that if you wanted to do more with your own students, you know, you could definitely.
So now I understand your pre-lab.
Yeah.
Because when I was helping you do things, you're telling me what to do.
Okay.
I didn't understand why you picked these in the pre-lab.
Uh-huh.
But now that you've explained it, I understand. Thank you.
Okay. Well, yeah. Thanks for.
Well, wait a minute, hold on.
No.
If you now understand, then we're done with this session because we have taught Stephen something, and as long as we teach Stephen something, we're good.
That's
We're
kind
done.
of our message. Did Stephen learn something? Okay, we did our job.
And we're done,
Yeah.
right. And we're evaluated as a 5 out of 5.
I think so.
Yeah, something like that.
Yeah.
All right, well, I think people want to see the lab part. They've said that.
Okay.
Yeah.
Okay.
Because we got to click on the oil and water. That's my favorite line.
All right, here we go.
Okay, so no, these are sand and water, milk and water, sports drink and water, whatever. These are not directly traced to the periodic table. These are mixtures. Now we've got to figure out what type of mixtures are these. So the next thing we're going to do is we're going to apply our test for the Tyndall effect. So Stephen is a genius, and he has formatted these so that they just play right on the page, which I love. And I hope this loads. I think this should load fairly quickly.
It should.
Yeah.
If I've done it all right, it should. I'm not a web person, but boy, have I learned a lot how to do things.
But you have the option to either play it directly here on the page. So I'll go ahead and do this one. Here's our sand and water. You can also click, and I believe you can bring up the full screen on the YouTube video. And what you're going to...
Just double click the bottom of it.
Okay.
See on YouTube. And we have no bandwidth in here.
Oh, that's good.
Sorry.
Even at Purdue.
Okay.
Oh, here it is. It is. So here's our Tyndall effect with the milk and water. Notice the beautiful glow that we see here. That's the Tyndall effect, all right? If we go here to this is our sand and water. This one got a little tricky. Those particles are really big, and they're really, and what did you call it? You called this
a very coarse sand.
Yeah.
It is a coarse sand, and so it settles towards the bottom. And so what they did when we recorded this is not shoot it towards the top, because you want to shoot through the particles.
Right.
So if you're using a coarse sand with all that dense, heavier sand, bigger sand particles that goes bottom, you'll have to run the light through the bottom and not the top. Otherwise, you're not actually getting the sand interference. You're shooting between the sands.
And that's a really good point, because it's those particles that are determining what type of mixture it is. So the more that we can shine that light through those particles, the better that Tyndall effect test is going to appear for us. So take a look at the sports drink.
Oil and water, that's cool.
I'm glad that you have these favorites. So here you can see it's spinning like the other one, but it's not really flowing. But the thing that we see though is we get the thing just over to the right, and you can see that beam of light shining straight to that backsplash on the lab bench. Those particles are pretty small, and they are not stopping that beam of light at all. Whereas when we shined it in the right spot with the sandy water through those particles, that was blocking it, but also we see kind of like a glow within that. The milky water definitely kind of glows. I like it when I hover over it.
So someone asked about using, so you recommend using it on a stir plate?
I recommend using it on a stir plate, but I have also, before I did that, when I was first doing this lab in the classroom, we did it really kind of, we just had to use what we had. We would have one kid stirring with the other kid trying to shine the flashlight through. That also works. You just have to get it, like we just use what we have. If you have a stir plate, that's awesome.
So we mentioned earlier we're using a laser, and it's just it's called, we got them from online, and it says cat toys, so you get a package of 3, and they're really cheap, but they work really well. Someone also mentioned they can get them from Dollar General and other places as well.
Okay, so we have 2 that are definitely scattering light, right? And they look like they're glowing. One that beam of light passed straight through. So now we need to decide, okay, well, if it's glowing, if that light is getting scattered, right? If we're observing the Tyndall effect, then we can move on to our next test, which is filtering. But the thing is if I grade out this one, where I did not observe the Tyndall effect, then I feel like the students are going to automatically know, oh, so this must be my homogeneous solution, because that's not a choice. So we went ahead and gave you all of the videos, because we don't want to necessarily give it away. Yeah. Because it wouldn't be given away if it was in the classroom. So just so you know, and this is also true when we do our lab, when we see that next section there, we're going to have a lot more tests, even though they won't all necessarily even be mixtures. I think we even do it with one of them that's a compound, because we don't want to necessarily give it away. If it's a liquid, we're going to do these tests, all right? So then we do the filter test. And so the thing about the filter test is if we observe the Tyndall effect, then we know that makes it a heterogeneous mixture. But then if it's a heterogeneous mixture, we need to determine, is it a colloid or is it a suspension? If we filter, and we have some of those particles getting caught on the filter paper, then it's a suspension. Taking forever. So I'm intentionally getting some of those particles to go through.
I didn't understand when we were filming. I
Right.
really had a problem with this. I'm like, are you fudging the data? What is going on? You're putting it in. You're putting it in.
Yeah, I'm
And-
purposely putting it in
But
there.
then when, I don't think you explained it well then, to be honest. But later, at this point now, today, I've understood more since we've done more design on it, that we're really checking the particles. And
Yeah.
so you have to make sure that the particles, it's not that she's cheating on the data, but the particles is what you're
Yeah.
testing.
We want to see, is that getting trapped by the filter paper or not? We're just using a coffee filter. We're not using any kind of fancy, whatever filter that you can get in a research lab. We're just using coffee filters. And that's going to be good enough for this class. Here we're going to run Milky Water because we observed the Tyndall effect. That light is getting scattered, the Milky Water is flowing. But if we try to filter Milky Water through a coffee filter, there is no particles left on that. That's all going down through that coffee filter. So those particles are large enough to scatter light, but small enough to go through a coffee filter. So that means that we can call that Milky Water our heterogeneous colloid. Sandy water will become our heterogeneous suspension. When we filter our sport drink, this one was interesting because there is a dye. Okay, and so it's I could see where some students would be like, well, it's catching the color. Okay, well, yes, it is. But also that if we look down through, that same color liquid is also coming down through. And the other piece of that is it wasn't scattering light. Those particles were too small to scatter the light. The light was passing straight through. So yeah, the dye particles,
It dyed the filter.
it dyes the filter. They're still very small particles. And so really we're going to classify that as a homogeneous or homogeneous solution.
I know the answer to this, but I
Okay.
want to make this concrete.
Mhm.
All right. So I start out, and once I know that this is, it either scatters light or doesn't scatter light, then I'm going to filter,
Yes.
right?
Mm-hmm.
When I filter, if I get something through
Mm-hmm.
onto the filter, there's something physically there, then it's a what?
Suspension. It's a heterogeneous. I already know it's heterogeneous because I'm filtering.
Okay.
And it's
So
a suspension if there are particles on the filter.
And if there are not, then it's a,
Colloid.
okay?
Mhm.
I think kids got to they got to keep hearing that again and again,
Mm-hmm.
because that's where they get confused, at least when I was teaching it.
Yes.
That's where they would get confused.
To be honest, that's where I would get confused. And I, as a chemist, I just want to call everything a solution because that's easy. It's all in water. It's all solution, right? And that's hard for me to kind of get that vocabulary. If we're classifying, we want to make sure that we're describing them best that we can. And so I catch myself sometimes. I just want to call it all solution.
So you're going back to Steve's going back to the flow chart
Mm-hmm.
so that they can see that.
Yeah.
Because that I think is very important visually for the kids.
Okay, so this is walking us through, we just walked through the pre-lab. You kind of see our thinking and how this has been set up. I always would go through examples with the students just so we could talk out. Yep.
We need to put, what was the little flow chart that you made
Mhm.
on the, what is this, a pre-lab? We need to put that up higher on the web page itself and have explanations for each one, like a mixture if then on both sides.
Mm-hmm. There are a lot of things we could do for this. One thing I want to point out that we didn't pull up yet that you might like to see, I like for the students to go through initially and complete that chart. And that chart is here on the guided notes worksheet. So again, it's going to prompt you to put a copy into your drive. This is just some basic questions that we have over all that information in the overview. But here you're going to see that chart. And as the students read through the overview, they're going to fill in from information. So that way they're kind of making sense of it as they're reading it. But then to check themselves, that's why I put this completed picture at the top of the pre-lab. So maybe you would want to grade this. Maybe this is just a check for the students. Maybe they won't even do it. But when they get to the pre-lab, whether they've read through the overview or not, they're going to see the correct way that this is on the pre-lab.
And that's why you're a great teacher.
Oh.
Seriously, because that's the
Yeah.
that's
Yeah.
the knowledge we want
Having
them to
known
have
what they do.
before they get to that point.
And we didn't pull this up ahead of time, but this is what that guided note looks like. And again, they can get all of those answers right from that.
Awesome.
So they asked, do you avoid using these specific substances in the pre-lab? The ones in the actual lab?
Mm-hmm.
Yes.
Yes.
Right? Yes.
Yes.
And these are just one example of things. There's infinite examples.
You guys can change this up every year if you wanted to have new things. The nice thing about what Sarah put together was now it's online.
Mm-hmm.
So if you have a kid that misses, you can have them go back and do this. Or if you just wanted to have them do this, you can do it online. I mean, it's kind of how you want to use it.
So the pre-lab, again, I just can't stress enough, is something that I would do as much as possible with a class, guiding them through that. Here we get to the actual lab, and now we have 10 samples. Where the pre-lab, we just had one of each. Now we're going to have 2 of each one. But this is where my guidance stops. Like if I'm in the classroom teaching this, we've already talked through how to go through each of those tests, where to look at the periodic table, is this a mixture, is it not a mixture, what these tests are. And now it's up to the students. So now we have our lab observation sheet. Again, you're prompted to put this directly into your Google Drive. And now we have it set up very similar to how we have the pre-lab set up. Out of the 10 samples, you're going to be able to test 7 of them for the Tyndall effect and potentially the filter. We are going to have for sure 2 each of elements, compounds, homogeneous or homogeneous solutions, heterogeneous colloids, heterogeneous mixtures. So for sure there are 2 of each one. And for each of these, again, there matters. The sample ID is here, so they can match these up, maybe or maybe not to the periodic table. Yes or no, is it a pure substance or mixture? And then testing from there. If we go back to the thing, this table is set up very similar to, first of all, how their lab observation sheet is. It should be exactly in the same order. This is where Stephen was saying that, he linked up the pictures. I like the cornstarch picture because you can just see, it's just like, it's the next best thing to being in person with this. You can see that texture. Fluffy, cornstarch, just that you can actually see the detail there. It's a really good picture. For each of those, they can click on them as best they can and see the dirty water.
I just did the soil.
Soils that they-
I didn't know which to do.
Mm-hmm. No, this is good, yeah. So this is going into the water. So imagine mixing this up water. And we see, again, we don't want to give anything away. So Bill and Stephen did a really good job. I was working on some of the handouts with this, and they were setting up all the Tyndall effect tests and then the filter tests and going through each of these. We don't want to give it away. We don't want them to automatically think, oh, well, this is a homogeneous solution or homogeneous solution, so I know I don't have to filter it. So they can decide based on what they're observing and what they're seeing, how to classify those. But then I know this question was asked before. So then when we get a pure substance, is it an element or is it a compound? And this is where that data analysis now. They've gone through each of these examples, whether you're doing this in person or you're using this virtual lab. Again, I'm prompted. Just I feel like the more times you see this, you won't be alarmed if you're not used to it. This is then what I would grade. So I would grade their observation sheet when they're going through and testing it and writing down their observations. But then this is what they're being graded on, is actually taking each of those substances and listing them. Which were the 2 elements? And why are you classifying those as elements? And which 2 were the compounds? And why are you classifying those as a compound? To be honest, these 2 explanations are probably going to be really similar. So a lot of times I would just have them give one explanation for both of them. But sometimes they were classifying them for different reasons. So it's kind of up to really the samples that you're using and how the observations that you're making. Here you're going to see, which 2 were the homogeneous or homogeneous solutions. And then for the heterogeneous mixtures, which 2 were the colloids and which 2 were the suspensions. And so this is where before when we said, so how are we knowing which You know, yeah, we have pure substance, but then which are the elements and which are the compounds? Well, again, remember that we were looking at the periodic table. We could directly trace those two boxes that were occurring on the periodic table. If we think back to our overview, gold was just AU. That matched up to one box on the periodic table, and that's our element. Elements are that the smallest you can go and still retain those properties, those two are the elements. The ones that have that ratio, so yeah, we can trace those boxes to the periodic table, but like our pyrite, right? We have 1 iron and 2 sulfurs, and it's always that ratio, Fe, F2, that those are the compounds. And the others will be our mixture.
Comments?
Okay.
First off, I got to go back to one.
Okay.
Jay McBride says, yes, you are
Okay.
a great teacher.
Oh.
Okay. So, on the lab observation sheet,
Mm-hmm.
if we could add one more column for their prediction of what they think it will be.
Okay, so I think right here is under the Tyndall effect test. That was kind of what I was thinking that they would then fill in there. So is it heterogeneous or homogeneous? When my students were doing this in the classroom, we used different samples than what I have listed here, but this is where they would list heterogeneous or homogeneous. So they would go ahead and make that prediction. If they thought it was a homogeneous solution, if the light wasn't getting scattered, they would go ahead and X out the filter test. And that way that would narrow down what they were filtering from there.
Okay, so there's kind of an answer.
Mm-hmm.
Clearly, if I've made a copy of this lab sheet,
You can edit it anywhere you want.
Any way you want.
See, there-
You can
so-
change it to, and please do. This is one
That's why
way.
we do it this way.
But yeah, we want it to, you should be tailoring it to your goals and how you would teach it in your classroom, because it's not going to work the same for you.
someone also mentioned that it would be nice to have students bring a sample from home,
Yeah.
right?
Yeah.
As an extension, which I think either as an extension or it could be even like, on the test.
Yeah.
You have to bring in a sample, and then you, on your test,
Mhm.
do your sample, and then that way that for sure they understand.
Absolutely. I want to say I did that. Like the kids would, well, and it wasn't even that I said, oh, bring in a sample. I had kids bring in samples.
Saying,
to
yeah,
want to know.
I want to know. I want to know if Mountain Dew does. It's like
Yeah.
people are going to want to know.
Yeah, absolutely.
They'll be curious.
Mm-hmm. Well, and then I feel like if you get to a point where the kids are wanting to bring in samples, this is awesome because now they're invested and they want to know, they're going to learn it better if they've made that connection to that material.
And then someone mentioned they do this same lab with unbreakable plastic test tubes, and they love adding the Tyndall effect. So,
Oh, good.
yeah, okay.
Yeah, yeah.
All right.
Okay. All right. So I will have, again, the request for an answer key at the top. I'll have answers for the guided notes, the pre-lab that we go through, and then this lab observation sheet, and then the data analysis. So I'll be able to send you, if you want those, great. If you want to fill out your own, that's perfect too. But if you complete that, I can send those off. It'll be after our couple days of virtual PD here, but we will get that emailed to you. Oh, sorry. And this brings up a great point. So here's Stephen's favorite. He likes the cooking oil Tyndall effect test. All of these video clips are housed on our Superheroes of Science YouTube channel. This is all, it's a bandwidth issue. There we go. But Stephen, what is Superheroes of Science?
Well, I'm watching it. It's my favorite.
I'll explain. So while he's doing that, I went ahead and put in the link for Superheroes of Science. And Superheroes of Science is the YouTube channel that Stephen and Sarah started years ago. And it's an opportunity for us to put multiple videos and opportunities for teachers to use different ideas in their classroom. We do everything from demos to ask the experts to teacher professional development to just about anything. So it's a great place for us to put all the different videos that they've collected. And then now we're starting to even use all these videos to put together units to help teachers teach content hopefully better.
One product that we have, we're really excited about. We spent a lot of time this last school year developing Kids STEM degree, but from the Kids STEM degree, we originally were creating these for K through 5. We ended up with some video submissions. We ended up making a middle school level 1 Kids 12, and it's just STEM degree. I don't know. I think we were trying to get away from calling it Kids STEM degree, but
Wait a second. It says elementary still there because I've not updated it to middle school.
But we do have a middle school one, and we will eventually end up with past a level 1 adult. We've started on with level 2, but each of these are cool because they're kind of enrichment days. A lot of graduate students here on campus have helped us come up with these videos. They're between 3 and 5 minutes about all different types of science. The idea is that you watch the video and you answer a couple of questions about the video, and you'll get a code. And there are 10 total videos for level 1. When you collect all 10 codes, we'll have a place to enter those 10 codes, and you get your own personalized Purdue University STEM degree. And it's kind of cool. It has your name, it has the date on it, has Purdue University logo. It's just kind of something fun for, like we said, for enrichment for students to do. I think we had quite a few teachers using it at the end of the school year, so the end of the spring semester. We noticed a lot of activity happening there, which we appreciated. I know it's giving us views, but I think also it's helping the students learn some kind of neat things from scientists here at Purdue, and they're getting a certificate with Purdue and their name on it.
So if you will, I don't ask much in this world, but if you could all go there and subscribe, if you're not already subscribed, that would also be of a huge benefit to us. We're not making any money. Once again,
No.
This is not a moneymaker.
My son is very disappointed. He thinks we should be monetized and making zillions of dollars. He gives me pointers regularly about how to get thousands more subscribers. His favorite YouTubers are just in a different level than we are. But
Thank you, Renee, for watching with your kids. I'm glad they like them.
The Science from the Experts, that's where we interview STEM professionals. We have those on video, but we also have those on all podcast players. So if you enjoy kind of hearing about some science or what some of our teachers have been doing with the podcasts, hey, Billy, you want to explain that?
Hang on, I
Oh,
was
you
answering
answered your question. All right. Well, a variety of things.
Sorry.
I know
Sorry.
in winter on snow days, which I don't know if they exist anymore, they were like assigning podcasts for the kids to do free response to.
Yeah.
We had teachers telling us they were doing that,
mm-hmm.
and we have over 100 different interviews. So we have like that.
The neat thing is these are all currently being researched. These scientists are learning or researching these topics today, right now. This is where the funding is happening in the field of science. So for one thing, that's awesome that this is where that research is happening. I know that another activity, so yes, the snow days or the virtual days where they can listen to a podcast and do it like a free response or a short paragraph about it. We've had some teachers telling us that they'll do podcast walks. So they'll have their students bring in some kind of device like a phone or an MP3 player or something to pull up a podcast, and they will assign the podcast, and they'll all go on a walk and listen to it, and then like for a class period, and then maybe the next class period they'll come back and they'll discuss what they were listening to. I thought that sounds pretty fun.
Did you share that link?
I'm working on it. Okay. There's one of the podcast links.
I know we also realized that sometimes
It's on all
YouTube is
players.
blocked.
So.
Yeah, YouTube at times is blocked on school sites. So it's nice that our podcast is also there as an audio.
I threw the Apple podcast one out, but it's on whatever podcast player that you use, it's on.
Okay, I'll explain once more. So the kids STEM degree, the kids watch a video, they take a small quiz. When they get their quiz, they get a code. And after they've done all 10 of them, they enter those codes in, and it will let them print off a certificate that basically says they now have a Purdue Kids STEM degree. And
It's all free. It does it itself. The kids watch the videos, take the quiz, get the code. And they put in the codes, and then it gives them.
And if you know anybody that teaches kindergarten through 5th grade, we have them for those as well.
You can get to our kids STEM degree from the Superheroes of Science YouTube channel. So there, we do have a playlist that will come up on the channel.
I was bragging about these.
Yeah, yeah.
This is
Zombie cicadas. Those guys were amazing.
What do you
Yeah,
want?
yeah.
I forgot.
Kids STEM degree.
Oh, playlist. Oh, it's one of the top.
Yeah. So we have science demos second, but then we have our kids STEM degree. And the link to the actual site, we have all the videos there. But if you go to the main site, then you can see the middle school.
Oh, you're asking them to take over.
So the main site here in our description, that brings you to our landing page for the kids STEM degree and middle school. Right now we have a level 1 for each of the grade bands, but we have a middle school level 1. We're slowly building our middle school level 2.
Yeah, yeah. And we do demos on Fridays?
Yeah.
Oh,
yeah.
You're all in
Oh.
we call a lot of things. We're doing demos on Fridays now.
Yeah.
I know at conferences I've done like demo workshops and stuff in the past, and those are always very well received.
Yeah.
And so we've talked about for a couple of years videoing and putting up some demos. That's what we're doing tomorrow afternoon, right?
Yeah. Tomorrow we'll have a session. Yeah, session with demos. So meet us tomorrow at 1 Eastern.
Someone asked, how do you get a hold of us if you want some help? I went ahead and put in, so we have I'll say a generic, but it goes to a nice system, and it's K12science@purdue.edu.
It's all of us.
And so that gets to all of us, and then if whatever you're asking, it can get tailored quicker to the person who can help you. Okay? But I do want to, because I know some people said they had to leave here in a minute. If you are wanting continuing education credits, CRUs, whatever they call them in your state, and so you want the 2 hours that we were here today, I'm going to put my email in there, and I want you to email me, and you need to email me, hopefully you'll have your name on your email, your name, and then I need the last 4 of your social security number. Okay? I don't need PIN numbers. I don't need your birth date. So don't give me anything else. I need the last 4 of your social, and then what I'll do is I will make you a certificate that will have the hours on it, and then I'll send it to you. So if you attend all the sessions for the next 3 days, I'm going to wait and do it all the way at the end. So don't expect them to show up like in the next 15 minutes, okay? So just understand, I had people last time, why isn't it here yet?
I should have this.
So if you are wanting continuing education credits, I'm putting my email in there now. I'm the one you want to email. Don't email K12 Science because may not see it for a little bit.
I saw those flash so fast, the
Yeah,
comments, so I only get to see part of them. But I saw someone asking about grants.
Yeah.
One of our old workshops because years writing grants is like our side job or this job. It's a huge part. Getting all the stuff that to be able to do things to get to you is we have to write grants to be able to do it. Purdue's not going to give us money to do that. But can't hear anything after you said email. Are we out? Hear me now. Hear me now. I don't think I touched anything. I can hear you. All right, someone can hear me. Okay. But I did. We put together. I don't know. It was 3 of us, 2 of us. Looks like it's 2 of us. Put together the how to write grants for your classroom or district, and that's just based on years of experience writing grants. Here's our things that I find are very helpful, and so you might look at that for input on writing your grants, because I kind of go through the important aspects, and I have fairly good luck writing grants. It's just higher than the average, we'll just say that, and so
I really liked going through that. I feel like Stephen does a really excellent job in that presentation, particularly of explaining or defining what a goal is, what an objective is, what an outcome is. And I think sometimes if you're not in that, you're not writing grants regularly, or if you're new to writing grants, I was pretty new to writing them, it's helpful just to hear these definitions, because this is what a lot of grant applications are asking you for. And it's easy to confuse your goal with your outcome, with your objective. So it's a nice way to go through and kind of get all that information straight. before you go through that grant writing process.
And as I talk and go through, I talk about metrics and stuff also in here. And again, I want to throw out one more time, one of our metrics is the interactions we have on our YouTube channel. That's one of the metrics that we use to help faculty get grants. And when faculty write a grant, they usually come to us. They're like, okay, I'm running this big research grant, but I need help with broader impacts. They'll come to us. We'll write up things like, oh, look, your group can help make a, what's it called?
A video or a lesson.
Yeah,
a
lesson.
virtual lab.
Virtual lab. Is that this?
Yeah. Yep.
Yeah, virtual lab like Betsy's.
Can you share the link of that video that you just sent out?
This one?
Yeah.
Yes, please.
Let's do this. What else is there?
That'll do.
Stop this. There. All right, that one's there. But things like okay, but I'm on the wrong one. So here on this page, these are all, it's people talk, I mean, it's, as you can see from all over, everything from ecology to, you know, the caffeine samples in coffees. And so, I need to look at that again.
Yeah.
I'm not probably, but faculty come to us, we help them write the broader impacts, and they come in and they do. If you do any ecology stuff, this one's really neat with Andrew, by the way.
Mm-hmm.
I really like that one. And Betsy, she's just the sweetest person in the world. It's slow down, you're talking. Yeah, I'm sorry. But so we have several of these that we've not put together yet, and that are partially put together that we're working on. And we have a lot of these that we have some teachers coming in this summer doing virtual labs. I'll put this link in, or you need to jump out.
We're getting the link.
The link for that?
For the
Yeah.
teaching
Oh, I can do
You
that.
can jump to that, right? I can take care of that.
Yeah, I'm sorry. That's good.
Sorry, throwing too much at you.
That's all right. I'll get there eventually.
But I mean, this is our thing. It's creating virtual labs or resources for you right now. It's kind of, it seems to be what teachers are asking the most. And if there's other things, if for you that's not quite hitting the mark, let us know. But like I was saying, the metrics that we use is, so please do subscribe to the channel.
Yes.
And if you see something you like, give us a shout out on it, hit a like on it, and things like that. Interact with us best you can, because that lets us know what's going to help you most. And that lets funders, because we only had like 200 people on our YouTube channel, and we put in, oh, we're going to disseminate this on our YouTube channel. And they're like, oh, wow, 200, go you. They might not give us as much or money at all. And so if the more people we can show that we impact, and that's one of the things we've discussed for us. We could make a lab like the lab you shared today.
Right.
If 1 million people use it, and we have no proof that anyone used it, it's our funders, the people who are funding us, giving us money to give you, they're going to be like, well, okay, great, but you don't have proof anyone used it. So interact with us best you can to help us get the money to continue offering things for you.
If you're
still looking at the microphone, I don't know why.
If you're looking to try to find, if you think, oh, hey, this is great, where do I get this lab now? 2 places, you can go 2 places. First, our channel. So again, Superheroes of Science on YouTube. The 4th playlist down, we're going to see Science for Kids. Trying to make everything circle back to these places where you can get them easily. You're going to see we have Kids STEM Degree in a different feed as well. Each Passport Day was another initiative that we had this past spring. It's kind of similar to STEM Degree, but you're going to see at the end of this list here, high school and middle school labs. And
there you go. Yeah, you were hitting play off.
okay, I'm still hitting play off.
No, you're not. No, that was correct. Yeah. That was
Beautiful playlist. I clicked on it. Beautiful playlist. There we go. If we go to view full playlist, this link right here is where we are going to be posting the middle school labs that we're presenting today and tomorrow.
Oh, you cut and paste that into there.
Well,
I gave him the other one, yes.
Okay,
I gave him that one right there.
This is where we're gonna put.
this is where we're putting this.
So you have the link for this website. I just put it up a minute ago.
We just wanted to show you that you can also get there from our channel. It is, the site is listed under high school and middle school labs.
That way, if you forget, you didn't get that link and stuff, you're like, oh, where can I find that? And you think about it next month, then you'll be like, oh yeah, that's right off their YouTube channel
Yeah,
that I
YouTube channel.
subscribe to.
Thank you.
One other question was asked, in order to get college credit, how much is it? We're not offering this as a paid class through Purdue University. We are just giving you your continuing professional credit.
Professional growth points.
Yeah, professional growth points, whatever they call it in your state. So you will be getting 2 hours for coming to this session. And so all I need is the last 4 of your social security number. And I put my email in there multiple times, wbailey@purdue.edu. And then I will get those filled out and sent back to you.
They're going too fast.
Oh, that's a great suggestion. Understands the next gen standards and can help us tag these with those standards so we get more hits on the material.
So Sarah, are you offering to do that? Okay, we can talk. Because there's times when honestly, when we have some money where we might be able to hire a teacher to do stuff like that. So, I'm not actually joking. That's not a bad.
I'm too busy to do it.
And she says I have certifications.
Oh, awesome.
Okay. Thank you. That's a great point.
Yeah. Thank you, and we appreciate that. And we are on social media. We're at Purdue
When we
SOS.
say tag, what do you mean by tag?
Do you mean on social when you
Like put
tag?
tags, social tags? I'm not sure the best place to do that to help people. Oh, that's good to hear. So what's the best way of letting people know that
Maybe
it falls under?
listed on our web page for the
Okay.
lab, maybe.
I know a lot of the things we've done last couple of years, we've tried to do, add the standards to the video. Oh, okay, way to
Yeah.
be straightforward on that one.
Yeah.
Well,
Kinda like,
I mean,
hey,
we tag it middle school,
Yeah.
PS1-1,
oh, right.
and then they know that that's what it is.
Good.
Oh, that's a good point. Yeah, on the videos. Yeah,
Thank you.
yeah. Thank you. That's
Sometimes it takes us a little bit longer.
Sometimes a lot longer.
awesome. Thank you. That makes sense.
Oh, there's a
On the
delay.
video.
Look.
That's just-
Okay. We are done with the lesson, and we are more than happy to answer any questions.